Hello, good morning, or evening, or night, everyone. Welcome back to our new plan video. Before the video starts, let us introduce ourselves. We are from Curve 6. We'll explain about measures of resin. Before the video starts, please subscribe, like, and share this video. Enjoy! Okay, we will start our video now. First of all, we must know what the meaning of variance is. Variance is measure of how far a collection of number is spread. Variance can be zero, positive, but never negative. The purpose of this discussion of variance itself is to use it so that we can find out about the diversity and distribution of some values presented in the form of group data. It also can give an idea of how the spread of quantitative data. To see the distribution and diversity of these values, we can see the results of the value of the variance. Variance that are zero indicate that all values of the data are the same. Variance is always non-negative. A low variance indicates that the data points tend to be very close to the mean and between each other, while a high variance indicates that the data points are very scattered around the mean and from each other. The lower the variance value, or the variance value is not equal to zero, then the lower also the distribution and diversity of data, although not all data values are the same. In this video, we will discuss variance in the group data, because the aim is to see the diversity of values and to see the distributions of data in order to give an idea. That is the reason why we must learn about variance. Variance itself has two types, namely sample variance and population variance. In this case, the sample is part of the population. The population includes all data based on a particular category, while the sample is only a part of the population and is usually chosen randomly for the populations. Population variance is represented by square root sigma, while sample variance is represented by square root of S. Of the two-type variance, it will be broken down into two cases based on the similarity and differences in the interval of each class. For more details can be seen as follows. First, for the same interval class. This is the formula. Sigma squared is equal to c squared times in bracket sigma frequency multiplied by deviation squared divided by measures of population plus r minus square root of sigma frequency multiplied by deviation squared divided by measures of population. Secondly, for the different class, this is the formula. Sigma squared is equal to 1 per measures of population times in bracket sigma frequency multiplied by square root of middle grade class I minus square root of sigma frequency multiplied middle grade class I divided by measures of population. This is, for example, for the same interval class. This is the formula. Square root of S is equal to square root of C times in bracket sigma frequency multiplied by deviation squared divided by measure of sample plus r minus 1 minus square root of sigma frequency multiplied by deviation squared divided by measure of sample minus 1. For the different interval class, this is the formula. Square root of S is equal to 1 per measure of sample minus 1 times in bracket sigma frequency multiplied by square root of middle grade class I minus square root of sigma frequency multiplied middle grade class I divided by measures of sample minus 1.
The interval in question here is class length. So, in determining the formula to be used, should be considered something such as 1. Pay attention to the variances that will be inserted, whether population variances or sample variances. 2. Pay attention to the interval of each class, whether equal or different. 3. Determine the formula that will be used either to determine the variancy of the population or the variancy of a sample. For the first and second formula, it is used to find the variances of the population, while the third and fourth formulas are used to find the variancy of the sample. For example, you will find a variety of shoe size from a school where the number of students is 400. If using 400 of those data, then we can use the first or second formula depending on the interval of each class. But when the student take 50 randomly as sample to find the variation, then we can use the third or fourth formula depending on the interval of each class as well. Case example. For example, from a community environment, you will be able to measure shoes from children to adults whose number is 50 people. Then from the result, it will be taken some random people, then calculate the variation. Data can be presented in the form of the table data group as below. Number 1, shoe size is 24 until 27 with frequency 2. Number 2, shoe size is 28 until 31 with frequency 6. Number 3, shoe size is 32 until 35 with frequency 3. Before we find the variation, we have to analyze first whether we are looking for it is a variancy of sample data or population. The total amount checked in the shoe size is 50 people, but the randomly selected in 25 people. In this case, the variancy sought is the variancy of the sample because the amount sought is 25 people. The possible formula used is the third or fourth formula. To determine which formula to use, we can see the size of the interval of each class. Interval of each class. M2 minus M1 equal M3 minus M2 equal M4 minus M3 equal 4, where M1, M2, M3 indicates the middle value of each class. 29.5 minus 25.5 equal 33.5 minus 29.5 equal 4. Because of the magnitude of each class interval is 4, or C equal 4, then the formula we use is the third formula. Next, we also specify the origin point of the assumption that M equal 61.5 is in class 40 until 43. Selection from the point of origin assumption should pay attention to the large frequency to facilitate calculation and influence the value of deviation. In this case, the biggest frequency is 7 and is in class 40 until 43. Because the point of origin of assumption is in class 40 until 43, then the value of deviation in this class is 0.
So obtained, number 1, the shoe size between 24 until 27, frequency is 2, the deviation is negative 4, deviation square is 16, frequency multiply deviation is -8. Frequency multiply deviation square is 32. Number 2, the shoe size between 28 until 31, the frequency is 6, the deviation is -3, deviation square is 9, frequency multiply deviation is -18, frequency multiply deviation square is 54. Number 3, the shoe size between 32 until 35, the frequency is 3, deviation is -2, deviation square is 4, frequency multiply deviation is -6, frequency multiply deviation square is 12. Number 4, the shoe size between 36 until 39, frequency is 5, the deviation is -1, deviation square is 1, frequency multiply deviation is -5, the frequency multiply deviation square is 5. Number 5, the shoe size between 40 until 43, the frequency is 7, the deviation is 0, the deviation square is 0, frequency multiply deviation is 0, frequency multiply deviation square is 0. Number 6, the shoe size between 44 until 47, the frequency is 2, the deviation is 1, the deviation square is 1, frequency multiply deviation is 2, the frequency multiply deviation square is 2. So, the sigma frequency multiply deviation equal 35 and sigma frequency multiply deviation square equal 105. The formula is S squared equal C squared multiply sigma frequency multiply deviation square divided by n plus minus 1 plus minus sigma f multiply deviation divided by n minus 1 square. So S square equal 4 square multiply 105 divided by 25 plus minus 1 minus -35 divided by 25 minus 1 square. So S square equals 16 multiply 105 multiply 24 square minus 1225 multiply 24 divided by 24 cubic and all square. So S square equals 16 multiply 60,480 minus 29,400 divided by 13,842 square. So the result is S squared equal 16 multiply 2.24 square equal 80.28. From the results, it can be seen that the resulting variance is 80.28, rounded up according to the rounding rule to 80, indicating that shoe size in the community vary greatly from 24 cm to 47 cm. In this case, the higher the value of the variance, also the more variety and distribution of this data. But to remember here, variance is basically never negative. Even though the variations of all the data are the same, the result variance value must be 0. The next question is, does determining the variance value of a data group require a measure of data centralization? Then, how does the size of the concentration of data on the variance of a data? The size of data centering is any size that shows the center of a cluster of data, which has been sorted from the smallest to the large and vice versa from the large to the smallest. The size of concentration that is often used is the mean, median, and mode. Because the size of data centering includes the mean, median, and mode, the size of data centering is very useful when we are trying to determine the value of the variance of a data. Implementation of the size of the concentration itself includes: number 1, in determining the deviations from a data certainly requires the highest class frequency in order to facilitate calculations, where the highest class frequency is called mode class frequency. In this case, the size of data centering is the mode of taking over in determining the value of the variance of a data. Number 2, in addition to mode, in determining the value of variance, both population variance and sample variance for unequal class intervals from a group of data require a middle value or aim, which is one element in determining the variance value of a group data. From the facts number 1 and number 2, it can be concluded that in determining the variance of the population and the sample, the size of the concentration of data, namely mode and median, are very influential in calculating the value of variance. For group data, basically, the size of concentration of data, that is the mean, is not used at all to determine the variance of group data, because the mean is only used for a single variance. Therefore, the value of variance and the size of the concentration of data are two things that influence each other, and not two values that have no relationship at all.
Okay, this is how to prove the formula of variance of sample for different interval class. First step, you can write it in sigma frequency is multiplied by the median minus the mean in square brackets divided by measure of population minus 1. Secondly and thirdly, explain it median minus the mean in square brackets, then using the letter of sigma notation, so that can write it sigma frequency multiplied by squared median minus 2 multiplied by mean multiplied 2 by sigma frequency multiplied median plus sigma frequency multiplied squared mean divided by measure of population minus 1. Step 40 until 60. Substitute sigma frequency multiplied median with mean multiplied by sigma frequency and simplify. So they can write in sigma frequency multiplied squared median minus sigma frequency squared mean divided by measures of population minus 1. For step 70 and 80, substitute the squared mean to sigma frequency multiplied by median squared divided by sigma frequency of square, and then eliminate sigma frequency with 1 per sigma squared sigma frequency, so that can write it in sigma frequency squared multiplied by squared median minus in bracket sigma frequency multiplied square of squared divided by sigma frequency divided by 2 measures of population minus 1. This is the last step and the last result. Substitute sigma frequency with n minus 1, so can write the last result sigma frequency multiplied by squared median minus in brackets squared sigma frequency multiplied by median divided by n min minus 1 divided by n minus 1.
The next question is, will in the two pieces of population data that have the same amount, the frequency in each class be the same and have the same range or interval but have different upper and lower ages, will have the same variance value? This will be shown as the data below. Data number 1. The shoe size between 23 until 25, the frequency is 2. The shoe size between 26 until 28, the frequency is 4. The shoe size between 29 until 31, the frequency is 5. The shoe size between 32 until 34, the frequency is 3. The shoe size between 35 until 37, the frequency is 6. Data number 2. The shoe size between 31 until 33, the frequency is 2. The shoe size between 34 until 36, the frequency is 4. The shoe size between 37 until 39, the frequency is 5. The shoe size between 40 until 42, the frequency is 3. The shoe size between 43 until 45, the frequency is 6. From the problems above, we know that the two data have the same amount, frequency, and interval. So, he can rewrite the information, which is 1. The same amount of data is sigma frequency 1 equals sigma frequency 2. 2. The same frequency is frequency equal frequency 1, 2 equal frequency 2, 1 until equal frequency 2, 5. 3. The same interval is C1 equals C2. Now, we'll look data number 1. In this data number 1, the value D equals 0 is in class 35 until 37 because the biggest frequency is in that class. Now we look data number 2. While in data number 2, the value of E equals 0, from the above data is at 43 until 45 because the highest frequency is in that class. Okay, from the above, because C1 equals C2, we can cancellate the two segments, and we will also assign both segments by half. The next step is to equate the denominator with n squared, so that the two segments, namely the left and right segments, are multiplied by n squared. From the above, we can describe it in accordance with the elaboration of the sigma form so that we obtain like below. Because in the problem, the frequency in each class is the same, then it causes the deviation in each class is the same. So, frequency 1 and 1 is equal frequency 1 and 2. Frequency 2 and 1 is equal frequency 2, 2. Until frequency 5, 1 equal frequency 5, 2. And deviation 1 and 1 is equal deviation 1, 2. Until deviation 5 and 1 until deviation 5 and 2. Now we look below. The two segments are divided by n. Sigma frequency multiplied deviation square plus minus and plus minus sigma frequency multiplied d square.
The next material is the standard deviation. In addition to variances, one of the measure of variation is standard deviation, or in bahasa Indonesia adalah simpangan baku. Standard deviation is essentially the root of the variances. Where each case of the variance is 8, it will form the formulation of the standard deviation. The default deviation itself is broken down into two cases, as the variance of the population and standard deviation of the sample. From both cases, it is also broken down into each of the two cases, seen from the interval of each class. The purpose of standard deviation is essentially the same as variance, looking at the homogeneity of the data and saying the distribution of data including group data. The greater the value of the standard deviation of data, the greater the variation and the distribution of data. If the value of the deviation is 0, then the value of the data is the same. But the value of the standard deviation of the data group is never negative. The emblem of the standard deviation itself is 2, namely the raw deviation of the population of the two, while the raw deviation of the sample or S. One of the last type of measure of variation is the distance value or abbreviated, or NG. Usefulness of this distance value itself is equal to variances as well as standard deviation. That is to see the data spread in group data and see variation. To get its own distance value can be done by decreasing the middle value of last class with middle value first class, or reducing upper limit of last class with first class lower limit. Briefly, it can be written as follows: ng equal middle value of last class minus middle value of first class, or ng upper limit of last class minus lower limit of first class.